Welcome to this video where we will show how modern PLM systems, specifically Windchill, support modularization and systems engineering. At CPC, we are experts in modularity and its implementation. Our experience shows that modern PLM systems offer numerous capabilities that support both modularity and systems engineering. One of the exciting findings is that these capabilities are available as out-of-the-box functionalities. In this demo, we aim to show you a real demonstration using these out-of-the-box functionalities in Windchill. In the video, we will demonstrate how you easily create module and system structures in Windchill by using a skid steer loader as an example. When designing a product, it's crucial to consider multiple perspectives to ensure a comprehensive and effective design process. One essential perspective is the system view. This view examines the product from a system perspective, focusing on its functional components. For example, in a skid steer loader, systems such as the cooling system, steering system, and power system are vital. The cooling system, for instance, includes all components necessary for cooling the skid steer loader, such as the cooler, pump, valve, sensors, and more. These systems define the product from a functional standpoint and are essential for capturing functional requirements. Another important perspective is the module view. This view represents how the product is physically built. Modules are often physical assemblies found on the assembly line. For example, a hydraulic module might include components like the hydraulic tank and hydraulic pump. While the hydraulic module encompasses many hydraulic components, it may also include elements from multiple functional systems, such as level sensors and pressure sensors, which are part of the control system. Both views are indispensable in the design process. The functional views are crucial for designing specifications and validating functional systems. Meanwhile, the module views are essential for constructing the product and ensuring manufacturability. Some may think these perspectives conflict, but we disagree. Both views should coexist harmoniously to create a well-rounded and efficient product design. Now, let us see how this looks in Windchill. We will start by introducing you to 4 views. First, the design view. The design view represents how the product has been created. This view is a one-to-one representation of the CAD structure and is driven by the CAD designer. Typically, CAD designers are not overly concerned with how the CAD is structured. Secondly, the system view. The system view shows each of the functional systems, such as cooling systems. This view focuses on the functional aspects of the product. Thirdly, the interface view. The interface structure shows all the physical interfaces between modules and design units. This view is crucial for understanding how different parts of the product interact with each other. The fourth view is the module view. The module view represents all the modules and how these modules are decomposed into assemblies and parts. This view is essential for understanding the physical buildup of the product. Each of these views is complete in the sense that they include all components and provide a complete 3D visualization. Let us start by looking into the module view. The module view is often referred to as the EBOM, Engineering Bill of Materials. In the module view, we can see the 3D visualization of a skid steer loader to the right and the modular breakdown structure on the left. Each of the purple icons in this structure represents a module. Here you see that the skid steer loader is built up by different modules that can be visualized individually. Let's open up the loader module and take a deeper look. As you can see, the loader arm module consists of multiple submodules. An example here could be the loader arm main module. This in turn consists of the loader arm right submodule. When navigating deeper into the structure, you will see blue icons. These represent design units. Design units are the smallest type of modules used in the structure. In this case, you will see that the loader arm right consists of a design unit called hydraulic cylinder vertical right. Upon examining the hydraulic cylinder, it is evident that this particular design unit is available in multiple variants. These variants are selected based on the specific configuration of the skid steer loader. More on that later. When isolating a single variant, you will see all the parts that make up the hydraulic cylinder. Notice that this design unit not only includes the cylinder itself, but also hoses, bolts, and nuts for mounting the cylinder to the machine. Now let us try to see how this cylinder is used. We start by selecting Where Used. Here you can see that the hydraulic cylinder is part of both the hydraulic system and the loading system. When we click on the hydraulic system, a 3D visualization of the complete hydraulic system is displayed, along with the full bill of materials, BOM, including all hydraulic components. This is a very powerful view for reviewing the design of the hydraulic system. And you notice that in this structure, we also find the hydraulic cylinder vertical right that we were looking at before. This is the same object as in the module view. If you make a change in the module view, it will automatically be updated in the hydraulic system view. Conversely, if you make a change in the system view, it will automatically be updated in the module view. This alignment is super important because if these views are not 100% aligned, maintenance would become a significant task. This alignment is a standard functionality within modern PLM systems, such as wind-chill. If we return to the where used view for the hydraulic cylinder vertical right, you will see small icons that looks like small hoses. Each of these icons represents all interfaces between hydraulic cylinder vertical right and other design units. Here you see an icon marked H. This is a hydraulic interface. Let us take a look at this interface. This is an interface between the hydraulic cylinder vertical right and the hydraulic valve block. The interface is an object that connects these two design units. When you turn on the visualization, you can see how the interfaces are connected. These interface objects are very powerful for understanding the impact of a design change. You can assign specifications, workflows, and approvals to the interfaces. We have now shown you modules, functional systems, and interfaces. Before we conclude this video, I want to return to the topic of design unit variants and configuration. To enable configuration in a PLM system, the structures must be overloaded. Overloaded means that the structure actually includes an entire product family. This is achieved by introducing design unit variants to the structure. We are now back in the module view where we are focusing on the body module. If we look at the submodule called Frame Body Right, we can see that it consists of multiple design unit variants. Variants are represented by blue icons with a red V. The overloaded BOM can be filtered down to a specific product variant by using the built-in configurator. In wind-chill, this feature is known as the option filter. By choosing different options in the configurator, you will see that the BOM has been filtered to one specific product variant. That is it for the video. Feel free to reach out to us if you would like to know more about how your company can benefit from combined modularization and systems engineering in PLM systems. Thank you for watching.